Topics: Functions of auxiliary boiler, steam supply system and system devices, and operation and maintenance of auxiliary boiler. Steam boiler or a boiler is basically a closed vessel into which water is heated until the water is converted into steam at required pressure. This is most basic definition of boiler. There are three ways that heat is transferred: conduction, radiation, convection, and all three means occur in a boiler. Conduction. Conduction is the flow of heat energy through a body or from one body to another in contact with each other, due to difference in temp. Example: in boilers, heat is conducted through the heating surface to the water. Radiation. Radiation is the transfer of heat energy from one body to another through space by rays of electromagnetic waves. Example: in a boiler, the heat from the burning fuel passes off in rays in all directions, striking the furnace walls, tubes, and other heating surfaces, raising their temps. Convection. Convection is the method of transferring heat through a fluid by the movement of heated particles of the fluid. Example: in the water tube boiler, the tubes are arranged to assist the convection current in the boiler, designed to take full advantage of the law of heat transmission. Boilers are generally divided into two types: fire tube and water tube. Fire tube boilers. In fire tube boilers, combustion gases pass through the inside of the tubes with water surrounding the outside of the tubes. Water tube boilers. In a water tube boiler, the water is inside the tubes and combustion gases pass around the outside of the tubes. A water tube design is the exact opposite of a fire tube. Marine fire tube, Scotch, boiler sample. Marine water tube boiler sample. Various uses of steam on ships. For main engine propulsion/turbines, in case of steam ships, for power generation, to run steam turbo generators, for running auxiliary machinery, in case of steam ships, for soot blowing, and for the steam atomized burners. For freshwater generation, evaporators, for firefighting, steam drenching, for heating duties, main engine fuel oil heater, galley supply, purifier, calorifier, galley, accommodation heating, sea chests, tracer lines for pipeline heating, for cargo heating, for fuel tank heating, for deck maki. Nary for running cargo pump turbines. Exhaust gas boiler. Steam can be produced not only by oil or gas-fired burners, but also by utilizing the substantial amount of waste heat in hot flue gases or exhaust air. Waste heat boilers use heat that would otherwise be wasted by exhausting into the atmosphere to heat water and make steam. A composite boiler arrangement permits steam generation either by oil firing when necessary or by using the engine exhaust gases when the ship is at sea. Composite boilers are based on fire tube boiler designs. The Cochrane boiler, for example, would have a section of the tube bank separately arranged for the engine exhaust gases to pass through and exit via their own exhaust duct. Steam boiler efficiency. The percentage of total heat exported by outlet steam in the total heat supplied by the fuel is called steam boiler efficiency. Steam boiler efficiency depends upon the size of boiler used. A typical efficiency of steam boiler is 80% to 88%. 6 important points that must be considered in order to improve boiler efficiency. Feed water temperature. To improve any system's efficiency, it is important to maintain the standard of all the inputs of that system. In boiler system, it is the feed water which plays an important role in deciding the overall efficiency. For this, the feed water temperature must be maintained at approximate 80 to 85 degrees Celsius to ensure boiler is operated at high efficiency. The hot well needs to be monitored for correct temperature and level. Any sudden fall in the level of hot well means more addition of cold water to maintain the level, which leads to reduction in the feed water temperature. Supply air to burner. Air is required to ensure adequate fire is generated inside the furnace through good combustion. It is therefore important to know the percentage of air for efficient combustion. For fuel oil-fired marine boiler with register type burner, 15 to 20% by weight of air is required for efficient combustion. Controlling excess air within the required range will lead to decrease in the flue gas losses. Excess air to be reduced or avoided. Know the air-fuel ratio for your boiler under its current rating. Keep a check on the content of combustion gases using flue gas analyzer to adjust the air-fuel ratio accordingly. Structural importance. The outer shell or structure is an important part which not only contains the pressure but keeps the temperature of the flue gas intact inside the boiler for better heat exchanging ability. Leakage from the boiler shell must also be checked. The insulation of the boiler must be checked for any damage or leakage. The refractory should be checked at least once in a month for their condition. Any damage in the refractory will lead to localized heating of the shell and damage to the same. Blow-down control. It is normally observed that boiler blow-down is not performed regularly by operators. Blow-down is only performed when the water test results are high in chloride or when high conductivity alarm occurs. This leads to uncontrolled continuous blowdown, which is actually waste of boiler heat and efficiency. Avoid continuous long blowdown. Regular short blowdown are recommended. Keep a regular check on boiler water chloride content. Ships provided with more than one boiler or steam generators must ensure that the load of the boiler is neither too low nor too high. The best operating range to get the maximum boiler efficiency is 2/3 of the boiler full load. If the boiler is operated below 50% load, more air is required to burn the fuel, which increases the sensible heat loss. It is always better to run less number of boiler at high load than more number at low load. Pro tips: highest efficiency of boiler can be achieved at 2/3 of the full load. Avoid running the boiler at below 25% load as the efficiency reduces significantly below this load. Soot deposits. The oil-fired boilers are prone to soot deposits in the tube and internal boiler surface, which reduces the heat transfer rate. A regular cleaning of boiler and economizer tubes must therefore be performed. Record and observe the stack temperature for indication of soot deposits. An accumulation of soot on the fire side of boiler tubes decreases boiler efficiency. When the flue gas temperature rises to about 20 deg C above the temperature for a newly cleaned boiler, it is time to remove the soot deposits. Steam supply system and system devices. Boiler feed systems. Types of feed systems. There are basically two main types of feed systems, number 1 open feed system, number 2 closed feed system. The main difference between an open feed system and a closed feed system is that in a closed feed system none of the parts of the system are exposed to the environment. Closed feed system is generally used in a high pressurized system such as a high pressure water tube boiler supplying steam to the main propulsion steam turbine, turbo generators, or cargo pumps in tankers. The main parts of a closed feed system are a regenerative type condenser, air ejector, extraction pump, deaerator, feed tank. Sample of closed feed system. An open feed system for an auxiliary boiler. The exhaust steam from the various services is condensed in the condenser. The condenser is circulated by cooling water and may operate at atmospheric pressure or under a small amount of vacuum. The condensate then drains under the action of gravity to the hot well. The hot well will also receive drains from possibly contaminated systems, e.g. fuel oil heating system, oil tank heating, etc. Open feed system for an auxiliary boiler. The feed filter and HOTWELL tank is arranged with internal baffles to bring about preliminary oil separation from any contaminated feed or drains. The HOTWELL provides feed water to the main and auxiliary feed pump suctions. Deaeration is the removal of oxygen in feed water which can cause corrosion problems in the boiler. HOTWELL is a tank or reservoir in which condensed hot water is collected from different steam lines. It's also called as cascade tank. It's an integral part of boiler feed water system. Purposes: collects condensed water. Supply feed water. The steam dump equipment is designed for dumping excess steam generated by the boiler plant from the steam system to an atmospheric dump condenser. It is essential that the condenser is dimensioned to be able to absorb the amount of steam generated in the exhaust gas boiler or exhaust gas part of the combined boiler. Boiler mountings. Auxiliary. Boiler external attachments and accessories. All marine boilers are required to be fitted with certain essential mountings. The minimum requirements are as follows: 2 safety valves, 1 steam stop valve, 2 independent feed check valves, 2 water gauges, or equivalent, 1 pressure gauge, 1 salinometer cock or valve, 1 blowdown valve, 1 low water level fuel shut-off device and alarm. Boiler equipment for safety. Water level gauges and indicators. Safety valves. 2 pieces. Combined high steam and low water safety valve. Fusible plug. The safety valve, which prevents overpressure, is one of the most important fittings. The spring-loaded pop-off safety valve pops open when steam pressure exceeds the MAWP. There is no routine maintenance on a safety valve. Safety valves are routinely tested to ensure proper operation. With the boiler pressure at a minimum of 75% of the safety valve set pressure, the safety valve tri-lever is lifted to wide open position. Steam is discharged for 5 sec to 10 seconds. Close examination and attention during overhauling. Check valve and seat for wear, cavity corrosion, pitting and any fault. Valve chest must be cleaned, condition and drain line clear. Hammer test to spindle for any crack and check its straightness. Hammer test to compression spring for any fracture and check for corrosion. Free length is limited to 0.5% of original free length. Check the guide plates and bushes for uneven wear and have sufficient clearance to allow free movement. Check compression nut and cover bushes, threads and any sign of wear and tear. Connecting pin should be a free fit in the lid and no bending. Pinhole to be regular shape. Safety valves routine check. Monthly, examine the safety valves for any leaking, such as, is water seeping from the drain plug at the valve body? Is the escape pipe hot due to seeping steam from the valve seat? Examine the drain and expansion device at the escape pipe. Examine the lifting gear device, i.e. clean up and grease all sliding parts. Yearly, the safety valve should be tested in operation by raising the boiler pressure. Expansion and exhaust pipe should be examined at the same time. Schematic drawings, safety valves. Steam stop valve. This valve, typically installed directly on the steam output fitting on the boiler, has several functions. It is primarily used to close the steam boiler from the downstream system when needed. It can also be used to slowly preheat the system following stoppages. It is also used to ensure minimum boiler pressure in the event of excess steam demand. The feed check valve as fitted to the boiler is normally a non-return globe valve, the chest being spigot into the boiler end plate. Some boiler makers fit a combined shut-off and feed valve, 2 valves in one chest, on both the main and auxiliary feed lines. The shut-off valve, a screw lift valve, is between the feed valve and the boiler pressure is under this valve. Water gauges play an important part in the safety of boiler operation. The water level gauge provides a visible indication of the water level in a boiler in the region of the correct working level. You should blow down a gauge glass periodically to remove any sediment from the glass. Types of water gauge. For boiler pressures up to about 20 bar, it is normal practice to use round glass tubes suitably connected to the boiler by means of cocks and pipes, for indicating the working level of the water. Above 20 bar, the glass tube is replaced by what is in effect a built-up rectangular section box having a thick plate glass front. The normal operating water level, NOWL, should be approximately in the middle of the gauge glass. The water column is blown down first and then the gauge glass to remove any sediment. Water should enter the gauge glass quickly when the gauge glass blowdown valve is closed. If the apparent obstruction cannot be removed by blowing down, then the boiler should be shut down and allowed to cool. For pressures above 20 bar, the round water gauge glass has been replaced by rectangular section box having a thick glass front and back. To test a gauge glass, the following procedure should be followed. Close the water cock and open the drain cock for approximately 5 seconds. Close the drain cock and open the water cock. Water should return to its normal working level relatively quickly. If this does not happen, then a blockage in the water cock could be the reason, and remedial action should be taken as soon as possible. Close the steam cock and open the drain cock for approximately 5 seconds. Close the drain cock and open the steam cock. If the water does not return to its normal working level relatively quickly, a blockage may exist in the steam cock. Remedial action should be taken as soon as possible. The authorized attendant should systematically test the water gauges at least once each day. Water gauge mountings should be overhauled at least at every boiler survey and, at this time, particular care should be taken to see that all passages through the cocks and also those through pipes and columns, if fitted, are clear. The maintenance of the correct water level in a steam boiler is essential to its safe and efficient operation. Samples of water level controls. Water level transmitter in all steam boilers is most important to have a constant water level in order to have a safe boiler operation and to maintain a good steam quality. The steam boiler is normally equipped with the following transmitters, for safety. Examples are low level, burner shutdown, low level alarm, high level alarm. For control examples: low level, pump start, high level, pump stop. The control level transmitter can also be a modulating type which can work according to the following principles: conductivity probes. Examples: float control, differential pressure cells. All pressure gauges on marine boilers operate on the Bourdon principle. The main component is a phosphor bronze or stainless steel tube of oval cross-section which is bent in the form of an arc being fixed at one end and free at the other. By applying pressure internally, the tube tends to straighten and the amount of movement at the free end is proportional to the pressure applied. The heating surfaces of any boiler, both fire and water tube types, may be kept clean, and the boiler thus be constantly available for service in an efficient condition. Soot blowers are fitted in suitable positions so that all the heating surfaces, tubes, superheaters, economizers and air heaters can be maintained in a clean condition, provided, of course, that the equipment is properly maintained and regularly operated, usually every 12 hours. The cleaning operation is performed by jets of high-pressure steam or air. Boiler drum internals. It is obviously an essential requirement for any boiler that steam supplied to the range or to the superheater should be free of water particles. Manhole. This is provided at suitable position on the boiler shell so that the man can enter into boiler shell for inspection, maintenance, and repairs. This hole is usually made in elliptical shape of the size convenient for a man to enter through this hole. The opening is closed by steam-tight cover. Manhole and handhole covers are removed to provide access to boiler parts during a boiler inspection. Before removing any covers, make sure all the proper permits and lockout-tagout procedures have been followed. Make sure the boiler is not in a vacuum by opening the boiler vent valve. As soon as the boiler has been dumped, open the handholes, remove the manhole cover, and thoroughly flush and wash out the water side. Do not dump a boiler unless it can be flushed immediately. If a boiler is dumped and not flushed right away, the sludge and sediment air dry on the heating surfaces, making it extremely difficult to clean. Boiler accessories for efficient operation: feed water pumps, superheater, economizer, air preheater, steam trap, condenser. Feed water pump. Function: it is a pump which is used to deliver feed water to the boiler. The appliances in common use for delivering the feed water into the steam boilers are: A. Reciprocating pump, B. Rotary pump. A superheater is a device used to convert saturated steam or wet steam into dry steam used in steam engines. An economizer is a device in which the waste heat of the flue gases is utilized for heating the feed water. The economizer on a boiler is used to add heat to feed water. Advantages of economizer: the temperature range between various parts of the boiler is reduced, which results in reduction of stresses due to unequal expansion. Evaporation capacity of boiler is increased. Overall efficiency of boiler is increased. The function of the air preheater is to increase the temperature of air before it enters the furnace. It is generally placed after the economizer, so the flue gases pass through the economizer and then to the air preheater. Combustion efficiency can be increased when air is preheated. Steam trap is used to collect and automatically drain away the water resulted from partial condensation of steam without steam to escape with this condensate through a valve. The valve after draining the condensate is closed. Is presses the leakage of steam from the trap. A steam trap allows condensate to pass through, but stops steam. Why steam traps? The duty of a steam trap is to discharge condensate, air, and other incondensable gases from a steam system while not permitting the escape of live steam. Reliability: experience has shown that good steam trapping is synonymous with reliability, i.e., optimum performance with the minimum of attention. Types of steam trap: thermostatic, operated by changes in fluid temperature. Mechanical, operated by changes in fluid density. This range of steam traps operates by sensing the difference in density between steam and condensate. Thermodynamic, operated by changes in fluid dynamics. The condenser is a heat exchanger which removes the latent heat from exhaust steam so that it condenses and can be pumped back into the boiler. A condenser is also arranged so that gases and vapors from the condensing steam are removed. It is also required to reduce the back pressure and so allowing a greater amount of work to be done by the engine, improving efficiency. Strainers. Pipe scale and dirt can affect control valves and steam traps, and reduce heat transfer rates. It is extremely easy and inexpensive to fit a strainer in a pipe, and the low cost of doing so will pay dividends throughout the life of the installation. Scale and dirt are arrested, and maintenance is usually reduced as a result. Pressure reducing valves. Where there is a possibility that the pipework downstream of reducing valves could be shut off during normal operation, a trapping point should be provided to drain any condensate formed during this period. This keeps the downstream pipework free of water and protects the reducing valve from filling with water and locking up. Float traps discharge condensate continuously and do not disturb the pressure in the pipe when discharging. Ejector. For most water-cooled condensers, the shell is under vacuum during normal operating conditions. Diagram of a typical modern injector or ejector. This diagram shows the basic components of an ejector used in the oil and gas industry. This ejector was designed for use with gas. It has similarities with the basic ejector shown in the above diagrams. The diffuser is designed to firstly mix the two incoming streams. Then, when mixing is complete, the diverging section slows the mixture down, thereby increasing its pressure. This is the reverse of the process occurring in the nozzle. Boiler safety devices. Safety devices on boiler: flame failure alarm, low water level alarm, very low water level alarm and cutoff, high water level alarm, low steam pressure alarm, low oil temperature alarm and cutoff, high oil temperature alarm and cutoff, low oil pressure alarm and cutoff, forced draft fan failure alarm and cutoff, power failure alarm. Safety valves. Samples of safety devices of the boiler. Boiler safety devices as for UMS status: flame failure, photocell shutdown combustion system and gives alarm. Low and high water level is maintained by feed pump, controlled by float operated on /off switch. Low and high steam pressure: if steam demand drops, high steam pressure will shut down burner and /or speed reduced. Low steam pressure alarm will be given if there is fault in combustion condition, fuel temperature, deviation from set temperature range, cause burner to be shut off, and alarms given for both low and high temperature. Fuel pressure: low fuel pressure cause automatic controller to shut down burner and alarms given. Smoke density: emitted smoke through uptake, being monitored, and if deviate from normal limit, shut down the system and alarm given. Air/fuel ratio: air register damper controller keeps correct ratio, and shut down the system and alarm given on deviation. Draft fan failure: air supply fan failure operate audible and visual alarms. Very low water level: burner stopped and alarms given. Very high water level: burner stopped or slow down and alarms given to avoid foaming and carry over. High flue gas temperature: burner stopped and alarms given. At ship, for burning low-grade residual fuel, burner is essential for atomization. Burner is a mechanical device which supplies the required amount of fuel and air to create a condition of rapid mixing and for producing flame. This mixing rate is very important as it decides the stability and emission of flame. Types of boiler burners. Pressure jet burner: this uses the pressure of the fuel oil to create atomization in a rotating spray. The fuel, at the correct viscosity, passes the center passage of the burner, so the swirl plate where the pressure energy is converted into tangential velocity energy. Rotating cup burner: it uses the principle of centrifugal force to increase the velocity of the fuel and thus achieve atomization. The burner unit comprises a heat-resistant steel cup, which is fixed to the end of a shaft that is rotated at high speed by an electric motor. Y-type burner: it atomizes the oil by spraying it into the path of a high-velocity jet of steam or air. Although either medium can be used, steam is usually more readily available and economical at sea. Steam-assisted burner: in this burner, when running at full power, the burner operated as a pressure jet burner and steam and hence water consumption was kept to minimum. Before making any attempt to start a burner boiler unit, the manufacturer's instruction manual should be read thoroughly in order to get a good understanding of how the burner operates. The operator should be familiar with the various parts of the burner and understand their function and operation. The burner should be checked over thoroughly to ascertain all parts are in proper operating condition. Some of the points to check are: fuel lines, all of the fuel connections, valves, etc. should be inspected thoroughly. Check all of the burner linkage for tightness and wear at connecting points. The electrical wiring should be checked very carefully. Operation and maintenance of auxiliary boiler. Safe operation of boilers. Boiler automatic burning system operation: with correct water level, steam pressure transmitter initiates cut-in at about 1 bar below working pressure. Steam pressure transmitter initiates master relay to allow air on signal to force draft fan. Air feedback signal confirms air on and allows 30 seconds delay for purge period. Then master relay allows electrode to strike arc. Arc striking feedback signal confirms through electrode relay and allows 3 seconds delay. Then master relay allows burner solenoid valve for fuel on operation. Fuel on feedback signal allows 5 seconds delay to proceed. As soon as receiving fuel on feedback signal, master relay checks photocell, which is electrically balanced when light scatter continuously on it. Result is OK and cycle is completed. If not, fuel is shut off, alarm rings and cycle is repeated. Steam pressure transmitter initiates cut out automatically at about 0.06 bar above W. Burner automatic operation flow chart. Typical marine oil-fired auxiliary boiler for cargo ships vertical water tube type. Note: operator and maintenance personnel must never bypass or defeat any of the safety controls and devices used on auxiliary boilers. Maintenance requirements for auxiliary boilers are contained in your ship's PMS manual. All personnel charged with the operation of an auxiliary boiler should be thoroughly familiar with the boiler, its controls, and all safety precautions. Operating instructions can be found in the appropriate manufacturer's technical manual. All boiler operators must be concerned with 2 hazardous conditions that could occur in a boiler when the automatic control system malfunctions. 1. Low water level. 2. Firing the burner should follow the procedure outlined in the specific burner operating instruction manual for the equipment being started. Check the condition of all auxiliary equipment that serves in firing or feeding the boiler, interlocks, limits, feed water supply pumps, etc. By this time all of the auxiliary equipment should have been checked out for proper size and pressure to ensure proper operation of the unit. Steps for firing up. When the boiler is closed, check and close the blow-off valves, water column, and gauge glass drains, and gauge cocks. Open the vent valves, gauge glass shut-off valves and steam pressure gauge valves. Fill the boiler with water at ambient temperature, but not less than 20 degrees Celsius. Fill to a level about 3 centimeters above the bottom of the gauge glass. Blow down the water columns and the gauge glasses, making sure that water returns to proper level promptly. Fuel piping should have been pre-tested for leaks. The oil pump sets should be started so oil can be circulating, and oil pressures adjusted to the burner requirements. If fuel lines are new or repaired, precautions should be taken to make sure these lines are clean. The strainers should be checked frequently. Steps for firing up. Start the burner on low fire in accordance with instructions listed in the specific burner operating instruction manual. The boiler should be warmed up slowly to permit temperatures to reach saturation temperatures and metal and refractory temperatures to equalize. As the boiler begins to warm up, it should be watched closely for leaks and also signs of expansion. When pressure in the boiler has reached 10 to 15 psi, close the drum vent. Combined oil-fired and exhaust gas boiler for cargo ships samples. Oil-fired boiler operation mode. When the main engine is stopped, the only heat source is the burners of the oil-fired boilers. The burner is operated by means of signals from the boiler gauge board and the steam pressure is kept within the set point limits. As the circulation pumps are operational, hot boiler water is pumped through the circulating system and the exhaust gas boiler is kept heated and pressurized. Exhaust gas boiler operation mode. When the exhaust gas flow through the boiler, produced by the main engine, is sufficient to maintain the steam pressure, the burners of the oil-fired boilers will not be in operation. If the exhaust gas flow is above the required flow to maintain the steam pressure at a given steam output, the pressure increases. At a pre-selected set point, the steam dump equipment, located elsewhere in the steam system, opens the dump valve and regulates the steam line pressure. If, however, the circulation outlet valve has been closed, the boiler pressure may rise above the maximum allowable working pressure. At this point, the safety valves open and ensure any further increase of the steam pressure. Normal boiler operation. When an exhaust gas boiler has been put into service, it requires only little attendance. However, the following items must be ensured. The circulation valves on both the exhaust gas boiler and oil-fired boilers must be opened. One of the circulation pumps must be operating continuously, also in port, while the other pump is in automatic standby start mode. The flow measurement system must be operational. Open the air escape valve once in a while to remove air pockets in the boiler. All alarms, especially circulation failure/start of standby pump, must be attended to immediately, and the cause must be established and rectified as soon as possible. The routine maintenance must be followed according to the recommendations. Dry running. Continuous water circulation must always be maintained through the exhaust gas boiler while the main engine is running. However, the design of the boiler allows operation without water with the full exhaust gas flow through the smoke tubes, provided the boiler is operated depressurized. Dry running must be limited as far as possible and only allowed in case of emergency if no other operation alternatives are present. Before start of the boiler, it must be drained and the manhole cover should be dismounted to ensure that it is operated completely depressurized. Please note that the temperature inside the boiler must not exceed 400 degrees Celsius. Combined operation mode. The steam production is controlled by the amount of exhaust gas from the main engine and the gauge board of the oil-fired boilers, which controls the burners. If the main engine produces an insufficient amount of exhaust gas to maintain the steam pressure, the boiler gauge board initiates start of the burner. The burner operates as long as the steam pressure does not exceed the set point for stop. If the steam pressure increases above this set point, the boiler gauge board initiates stop of the burner. Stop to normal standby condition. The main engine can be stopped at any time without special preparations regarding the boiler plant. The circulation of water through the exhaust gas boiler must be maintained after stop of the main engine for the following reasons. The boiler is kept heated by the oil-fired boilers and therefore ready for start of the main engine. A soot fire may develop even after stop of the main engine, and if the tubes are not properly cooled, this may result in severe damage to the boiler. External corrosion of the boiler tubes due to sulfuric acid is reduced. Stop to cold condition. Stop to cold condition is generally the same procedure as stop to normal standby condition. If required, the circulation pumps can be stopped during prolonged stays in port. However, not earlier than 12 hours after the main engine has been stopped and provided that no abnormal conditions have occurred during the cooling period, e.g. small soot fires. The boiler water circulation must be re-established prior to the next start of the main engine. Emergency stop. The boiler must be taken out of service immediately if a substantial loss of water is noted. The safety valve cannot function. Oil in the boiler water is detected. Too high salinity level is detected. Boiler maintenance. Boiler daily maintenance. Check water level. Upon entering the boiler room, check to ensure there is water in the gauge class. Blow down boiler. Blow down boiler in accordance with the recommendation of your feed water consultant. Blow down water level controls to purge float bowl of possible sediment accumulation. Check combustion visually. Look at the flame to see if something has changed. Changes may be an indication that a problem is developing. Boiler daily maintenance. Treat water according to the established program. Add chemicals and take tests as outlined by consultant. Record boiler operating pressure or temperature. Excessive steam or water temperature drop will alert you to excessive loading on the boiler. Record feed water pressure and temperature. Change in pressure or temperature may indicate a problem is developing with feed system. Record stack temperature. Changes in stack temperatures could indicate a boiler heat transfer problem. Boiler daily maintenance. Record oil pressure and temperature. Changes in pressure and/or temperature could have an effect on combustion in the boiler. Record oil atomizing pressure. Changes in pressure could have an effect on combustion in the boiler. Record boiler water supply and return temperatures. Check temperatures to detect system changes. Record makeup water usage. Excessive makeup water could be an indication of system problems in both steam and hot water systems. Boiler weekly maintenance. Check for tight closing of fuel valves. Check to ensure fuel does not flow through the fuel valve, when the burner is shut off. Check fuel and air linkages. Check to ensure all set screws on linkages are tight and securely holding the linkage in place. Check indicating lights and alarms. Check for burned out or loose light bulbs. Also check to ensure the alarm bell or horn sound on the appropriate shutdown condition. Boiler weekly maintenance. Check operating and limit controls. Check to ensure the controls shut the burner down at their predetermined set point. Settings should be verified with actual pressures and temperatures on the boiler gauges. Check safety and interlock controls. Check to ensure the controls shut the burner down at their predetermined set point. Settings should be verified with actual pressures and temperatures on the boiler gauges. Check for leaks, noise, vibration, unusual conditions, etc. Check operation of all motors. By developing a routine, any change in operation or bearing temperature will usually be caught in time to avoid a failure. Boiler weekly maintenance. Check lubricating levels. Check levels of any oil bath filters, oil level in air/oil tank, oilers on pumps, etc. Add oil in accordance with the manufacturer's recommendations. Check flame scanner assembly. Using the appropriate meter, check the flame signal strength at the program relay flame amplifier. Ensure the scanner assembly is clean and dry. Check packing glands on all pumps and metering devices. Proper tension on packing glands will extend life of equipment. Boiler weekly maintenance. Check gauge glass. Ensure there are no cracks or etching in the glass or leakage around the packing. Check operation of water level controls. Stop the boiler feed pump and allow control to stop the boiler under normal low fire conditions. See your operating and maintenance manual for a more detailed procedure. Boiler monthly maintenance. Inspect burner operation. Analyze combustion. Take the flue gas analysis over the entire firing range, comparing these and stack temperature readings with previous month. Inspect for hot spots. Inspect the boiler to ensure no hot spots are developing on the outside of the boiler. Hot spots can indicate a refractory failure or baffle failure, thus causing improper gas flow through the boiler. Inspect burner operation. Visually inspect the pilot flame, main burner flame throughout the firing range, free movement of linkages and general burner operation. Check for flue gas leaks. Ensure something hasn't changed in the breaching, stack or overall system that allows flue gas to be drawn into the boiler room. Boiler semi-annual maintenance. Clean low water cutoffs. Remove head assembly or probes, inspect and clean out any sediment or contamination in the column or piping. If the condition exists, determine why. Check oil preheaters. Remove the heating element and inspect for sludge or scale. Clean oil pump strainer and filter. Ensure they are not plugged, thus reducing the flow of the required oil to the burner. Clean air cleaner and air/oil tank. Inspect and clean out any sediment or contamination. Add oil in accordance with the manufacturer's recommendations. Check pump coupling alignment. Check alignment of all couplings to ensure the tolerances are within the manufacturer's recommendations. Boiler annual maintenance. Clean fireside surfaces by brush or use a powerful vacuum cleaner to remove soot. After the cleaning process, and if boiler is to be left open, it is advisable to spray all fireside surfaces with some type of corrosion preventative. Clean breaching. Inspect breaching and stack and remove any soot buildup. Clean waterside surfaces. Remove all handhole and manhole plates, inspection plugs from water column tees and float. Thoroughly wash all waterside surfaces. Check oil storage tanks. Oil storage tanks should be inspected for sludge and water accumulation. Check fluid levels on all hydraulic valves. If any leakage is apparent, boiler annual maintenance. Check gauge glass for possible replacement. If internal erosion at water level is noted, replace with new glass and gaskets. On all unattended boilers, the gauge glass mounting should be of the safety style with stop checks in case of glass breakage. Remove and recondition safety valves. Have them reconditioned by an authorized safety valve facility. Check on the condition of the fuel pump. Fuel pumps wear out and the annual inspection time is the opportune time to rebuild or replace them. Boiler feed pumps. Strainers should be reconditioned. Feed pump elements wear and must be replaced. Boiler annual maintenance. Condensate receivers should be emptied and washed out. Make an internal inspection, if possible. If the receiver has a makeup valve mounted, it should be overhauled and checked for proper operation. Chemical feed systems should be completely emptied, flushed, and reconditioned. Metering valves or pumps should be reconditioned at this time. Tighten all electrical terminals. All terminals should be checked for tightness, particularly on starters and movable relays. Inspection of boiler exhaust gas side. The exhaust gas section should be inspected at least once a year. During this inspection, the following issues should be taken into consideration. Check the welding in the exhaust gas section. A careful examination should be carried out with respect to any possible corrosion or crack formation. Check that the smoke tubes and stay tubes are intact and that soot deposits are within normal limits. Check that the inlet box and outlet box are intact and that soot deposits are within normal limits. Inspection of boiler steam/water side. The boiler water side, interior, must be carefully inspected at least once a year. At these inspections, hard deposits, corrosion, and circulation disturbances can be found at an early stage and preventive measures must be taken to avoid unexpected material damage and boiler breakdown. The presence of hard deposits at the boiler tubes reduce their heat transfer properties and decrease the capacity of the boiler. Further, it can be established whether the feed water treatment is satisfactory, and whether the blowdown is carried out sufficiently. Insufficient blowdown will cause accumulation of sludge in the bottom of the boiler. Incorrect feed water treatment is commonly causing hard deposits or corrosion. If hard deposits are not removed, it may lead to overheating. Cleaning smoke tubes. The main engine exhaust gas contains carbon particles and unburnt residues, soot, etc. And the amount is strongly dependent on the state of the engine and the supply of scavenging air. These soot/unburnt residues will accumulate on the boiler heating surface if not removed by cleaning. Furthermore, the combustion quality of the engine is changing together with the load, where the best combustion is in the high load range and the lower range is giving a more contaminated, black/colored, exhaust gas. And the more contaminated the exhaust gas is, the more fouling will appear in the exhaust gas boiler. Therefore, it is impossible to specify exact time intervals in which the smoke tubes should be soot cleaned. Water washing procedure. The most effective way of soot cleaning is water washing, as most of the deposits consist mainly of non-soluble particles held together by a water-soluble bonding material. Water washing will have the following benefits: dissolves the bonding material, washes the loosened insoluble deposits away. Water washing must be carried out when the main engine is stopped and the boiler has been cooled down. However, the boiler should be warm enough for the water to evaporate so that the tubes will not remain moist after washing. Both fresh and sea water can be used. However, if sea water is used, the boiler must be thoroughly washed afterwards with fresh water in order to remove all salt deposits. Where deposits are highly corrosive or bonded, a soaking spray with a 10% soda ash solution is advisable before washing. Boiler feed water pump maintenance. During periods of operation, there is very little that can be done except to check it periodically to make sure everything is functioning normally. Bearing temperatures should be checked and the vibration can also be observed. Packing gland adjustment can be done and, depending on types of lubrication methods employed, lubrication of the bearing can be done. At that time the bearings should be checked carefully, lubricant replaced or added. Flexible couplings should be opened up, checked for wear and alignment, washed out thoroughly and reassembled with new lubricant. During the same inspection, the pump seals can be inspected and, if necessary, replaced. Feed water treatment. The treatment and conditioning of boiler feed water must satisfy three main objectives: continuous heat exchange, corrosion protection, production of high-quality steam. Feed and boiler water, boiler and feed water should be chemically treated in order to avoid corrosion and scaling in the boiler. In most vessels, makeup/feed water is distilled by an evaporator, and the distillate is generally very good makeup water. In practice, most distillate used contains minor parts of various salt combinations, which can be chemically treated away. Further, the distillate may contain dissolved gases like, for example, oxygen, O2, and carbon dioxide, CO2, which may lead to corrosion in the boiler, steam, and condensate system. Scale formation in boilers leads to lower efficiency because of reduction in heat transfer rates. Overheating and tube failures may result, and often the high cost of chemical cleaning may be entailed. Typical constituents of scales and deposits in boilers are calcium carbonate, calcium sulfate, calcium and calcium phosphate, complex silicates of magnesium, iron, and copper oxides, sodium, aluminum, magnesium hydroxide, magnesium phosphate. Boiler corrosion. Electrochemical corrosion. Hydrogen ions are generated by acid concentration under hard dense deposits and can penetrate grain boundaries of tube metal. Hydrogen attack can occur very rapidly, causing the tubes cracked, failed, and ruptured. General wastage occurs when pH value is 6.5. Pitting, air bubble pitting and scab pitting, occur when pH value is between 6 to 10 in the presence of dissolved oxygen. Corrosion. The presence of oxygen in the feed water can cause serious effects on the metals of the system. It can give rise to feed line corrosion with the formation of corrosion products of iron and copper and a simultaneous reduction in the effective thickness of the metals used to construct the feed system. The most serious aspect of corrosion in the feed line is that the iron and copper oxides thus formed are carried further through and will tend to accumulate in the boiler, even if adequate blowdown has been regularly carried out. Caustic cracking corrosion. Intercrystalline cracking occurs when excess concentration of caustic soda, NaOH, in boiler water, comes in contact with steel under stresses and high temperature. Metal becomes brittle and weak. Damage occurs to riveted seams, tube ends, and bolted flanges. Prevented by dosing sodium sulfate, Na2SO4, to give protective layer. Ratio of Na2SO4 to NaOH should be maintained 2:5. Corrosion by oil, animal or vegetable oil decomposed to fatty acid and causes corrosion. Causes are over-lubrication of machinery, leakage of heating coils and inefficient filtering of feed water. Prevented by liquid coagulant treatment, which coagulates oil droplets and suspended solids and settle them at low points, and they can be blown down. Corrosion by galvanic action, with dissimilar metals in a saline solution, galvanic action results in more anodic metal corrodes. Corrosion occurs when feed water is contaminated with salt water. Prevented by carrying out chloride test daily. Chloride level should be 0 to 300 ppm, and blow down if 300 ppm. CO2 reacts with H2O to form carbonic acid, H2CO3, which reduces pH value, alkalinity, of feed water and accelerates general type of corrosion. Groovings along the pipe's bottom, bends and threaded section. Feed and boiler water analysis. Boiler water testing. Marine engineers must make following analysis of the feed and boiler water in order to have a good treatment. pH, conductivity, total alkalinity, chloride, hardness, chlorine, iron, phosphate, hydrazine. Why analyze the boiler water? The water required for boiler feed purposes in example for steam generation should be of very high quality and thus requires a lot of treatment. Untreated water, containing impurities may lead to the following problems in boilers: scale and sludge formation, boiler corrosion, caustic embrittlement, priming, and foaming. Proper treatment of boiler feed water is an important part of operating and maintaining a boiler system. As steam is produced, dissolved solids become concentrated and form deposits inside the boiler. This leads to poor heat transfer and reduces the efficiency of the boiler. Dissolved gases such as oxygen and carbon dioxide will react with the metals in the boiler system and lead to boiler corrosion. Foaming and priming in boilers. Boiler water carryover is the contamination of the steam with boiler water solids. This is called foaming and it is caused by high concentration of any solids in the boiler water. Priming is the carryover of varying amounts of droplets of water in the steam, foam and mist, which lowers the energy efficiency of the steam and leads to the deposit of salt crystals on the superheaters and in the turbines. Foaming, formation of thick layer of steam bubbles, on top of water surface inside boiler. Priming, rapid carryover of large amount of water, in steam as it leaves the boiler. Causes and effects of foaming and priming in boilers. Causes: higher water level than normal. High amount of TDS, total dissolved solids. High amount of suspended solids. Contamination by oil and other organic substances. Forcing the boiler. Effects: water hammer, contamination and scaling, fluctuation of working water level. Salinity indicating system. A salinity indicating system is installed to detect the presence and source of salt in the feed water system and thus guard against its discharge to the boiler. There is a salinity indicator panel mounted on the main operating platform near the main switchboard. This panel indicates the salinity readings measured by cells located at main condensate pump suction, auxiliary condensate pump suction, feed pump suction, atmospheric drain tank. Chemical feed system. Provision is made in the feed piping for injecting boiler compound into either boiler while in operation. The system consists of a chemical compound feed tank and all the necessary piping, valves, and fittings, and is arranged to discharge chemical compounds from the compound feed tank to each of the boilers, using feed pump discharge pressure. The compound tank has a capacity of approximately 5 gallons. The purpose of chemically treating feed water is to turn scale-forming salts to a non-adhering sludge. Boiler blowdown. Many difficulties in boiler operation occur because of excessive concentrations of sludge, silica, alkalinity, chlorides, or total dissolved solids. To prevent an excessive accumulation of dissolved and undissolved solids which will interfere with proper boiler operation, a blowdown program should be established. The amount of blowdown or number of times the boiler is blown each day depends upon the concentration of solids in the boiler water. When necessary to blow down the boiler through the blow-off valves, they should be opened slowly and carefully. The boiler should be blown down at lower firing rates. Blow-off valves should be closed tightly after blowdown is completed. Soot blowers. Boiler tubes and heating surfaces get dirty because of an accumulation of soot, slag deposits, and fly ash. These substances are excellent insulators and reduce the effectiveness of the heating surface. Therefore, they must be removed to ensure the continuation of optimal boiler performance. Removal can be accomplished by using a hand lance or a soot blower. Steam and compressed air are usually used for blowing, although water and shot are sometimes used to remove certain types of deposits that become baked hard and are difficult to remove with the conventional soot blower. The operation of soot blowers is called blowing tubes. Tubes are blown on the following minimum occasions: after leaving port, before entering port, after making heavy smoke, once each week when steaming. Soot blowers are normally used water tube boilers. Before using soot blowers on a boiler, drain soot blower lines. Bridge must be informed before blowing. Boiler accidents. These are caused by low water level, poor operation and maintenance, and others. Furnace explosions. During this past year, a number of boiler furnace explosions have occurred and have resulted in several deaths and many injuries. A furnace explosion is usually a result of instantaneous combustion of flammable gas, vapor, or dust that has been allowed to accumulate in the boiler. Precautions against furnace explosions may include: ensure that fuel valves on non-operating burners do not leak. Ensure that fans, dampers, and burners are in good condition. Purge the furnace each time before igniting the first burner. Ensure that fuel controls and flame safeguards operate as required. Ensure the air intake is open and the stack is not obstructed. Ensure that fuel system is free of contaminants. Ensure proper fuel/air ratio. Do not use soot blowers to blow soot in a cold boiler, and clean and service the guns before reuse. Seawater in the boiler. If the boiler had to be operated with seawater, the salinity will rise rapidly since the salt remains in the boiler while the water boils off. Salt will sun precipitate and accumulate on the bottom and also on the heating surface, where it, just as boiler scales, inhibit the heat transmission to the water and causes the metal to overheat and in worst case burst. You may also get foam in the boiler that will cause difficulties to maintain the water level, and water droplets might follow with the steam, causing problems with turbines and engines. It is very dangerous to operate a boiler with salt in it, and you have to control the salt concentration by frequently blowing off from the bottom of the boiler and form the water surface to keep the salinity below 9.5%. Boiler makers and classification societies may recommend other values. Oil showing in the water level gauge glass. Stop the burner immediately. Oil present, even small quantities, in boiler water will cause foaming and moisture carryover. It also forms a heat insulating film, sometimes a carbonized layer, over tubes or shell surfaces. Even a very thin layer may result in tube or plate material failure due to overheating. The oil manifests itself by forming an oily ring inside the water gauge glasses, at the water level. Conclusion: improving boiler life and reducing accidents. Use a boiler as intended, observe water chemistry, maintain safety devices, and boiler service is key. Auxiliary boilers. Operation and maintenance. The end.